Hi, everybody. This is your week 2 welcome video. So I want to talk about a few different logistical things, and then we're going to talk about graphics of the day as you get started with this next week. So the first thing I want to do is for you to each take a moment and congratulate yourself. There's a lot going on in this course, and you are already onto week 2. You already know how to use R a little bit, right? You've already been introduced to some important conceptual ideas that give you a foundation. So you are doing a great job if you are already watching this video. Congratulations. So the next thing I like to do at the beginning of each week is just prompt you to have a moment of self-reflection. How did this week actually go for you? Did you feel like you started working on the materials in time to finish them when you wanted to? When you were at lab, did you feel like you were fully prepared for lab? Did you feel like you were able to use that time the way it was meant to be used, right? Had you tried enough of each problem so that you were able to already have some questions for the TAs? And your classmates? Had you already looked at all the quiz problems for that half of the week by the time you got there? Were you prepared to work on the problems that were happening at lab? And if not, how can you adjust your schedule now that you kind of see how the flow of this course goes, so that you can watch. So you'd be looking for some posted lectures, lecture modules, along with surveys, just like last time. Some of them are due before your first lab, and some of them are due before your second lab, so that's all the same. One thing that will be different this week is that for each lab, you will start by going to a separate Zoom meeting, not the main class Zoom, but a Zoom meeting hosted by one of the people in the lab, maybe you, maybe one of your peers. And you should have started an email chain with each of your lab groups last week so that you have a Zoom link that you can go to for those 20 minutes. If you look at the course outline, you will see that it now includes 2 lines that for week 2 that were not there in week 1. And those are instructions for exactly what you're supposed to do during your 20-minute meeting for your first lab, and instructions on exactly what to do during your 20-minute meeting for your second lab. So that is not just general discussion time. It's not always focused on graphics of the day. Rather, I have very specific instructions for what you are supposed to do while it is just the group of students without the TA. And then, of course, you go back to the TA after 20 minutes and rejoin the TA in the Zoom room. Remember that you are recording those meetings. Please don't forget to record them, and please don't forget to submit the Zoom link if you are the one hosting it. Please remember to record to the cloud. It's not that helpful to me if you submit a file path to a document that's stored on your computer. So remember to record to the cloud and submit the link. And also remember, it's being recorded and your peers are depending on you. So one of the reasons we're doing those 20-minute meetings is to try to help motivate you to get the work done before lab on time. And of course, the other reason is that I think it's helpful for the group of students without the TA to have a few minutes to think through the ideas and figure out what their questions are before someone on the teaching staff just kind of starts to feed you answers. I'm trying to make you struggle with the ideas a little bit, because that's the way you're going to learn before anybody just tells you how it works. Remember that when you look at both the assignment and the quiz, each problem is labeled with instructions for when you want to have thought about it. So the quiz questions are things to think about before your Thursday to Saturday lab, and things to think about before your Sunday to Tuesday lab. And similar, if you go down the questions in the assignment, some of them are labeled, think about this before lab so you can work on it there, or be ready to work through this problem at lab, or there's a data ethics module on this week, so it's read the articles and look through the materials before you're going to be talking about those materials with your peers. So do look over the quiz and assignment before each lab to make sure that you are prepared for everything you're supposed to be prepared for at that time. One piece of feedback I have based on just watching people's materials come in this week is I recommend not submitting the quizzes early. Remember that we can discuss the quizzes all week. And so, you may find that at a Tuesday office hour, somebody asks about a quiz question and you have an epiphany about that question, maybe in a way that you didn't quite understand it before. Remember that the quiz questions are multiple choice, and we will talk you through every single one of them. So you should be able to get all those questions right if you take the time to think about the material before you are speaking to the teaching staff and really get all your questions answered. But I don't recommend submitting the quiz like on Saturday just because you think you know the answers. Just hold on to it, write down the answers you think you have and submit it a little bit later so that you can let all your thoughts percolate and to give you a kind of longer time to make sure that you fully understand all the questions. And I think that'll make sure that the scores are all as high as they should be, although they were in general very good this week. Asked a question, which is what's the best way to take notes? And that's a good question. That's a good question for any remote course. And I have an answer. My suggestion is that you take notes in a notebook with your hand or on a tablet with your hand, and a pencil and a pen, the same way you would if it were a live lecture course. So when you're watching a video module, get out your notebook and take notes so that for this course, just like any course, you end up with a notebook or a tablet full of your own notes. The fact that it's recorded on a video you could go back to does not mean that you should just stare at the video without trying to learn anything or try to write anything down. And that is because the process of writing it down is part of what helps put it in your brain, right? And that's especially important, honestly, in a summer program like this one that does not have exams. So I am not forcing you to go back to this material in preparation for an exam that's going to give you a grade that shows up on your transcript. And I know that means that you just have fewer opportunities to make sure the material is ingrained. But writing down notes as you watch lectures is one of the ways you can make sure that you're giving your brain opportunities to understand and retain the information and figure out what questions you have. So I strongly recommend taking notes that way. The exception is if it's an R video, if it's instructions on how to use R, it's really not very helpful to just write down R commands. So rather, I suggest in those cases that you download the R file that goes with the R module and try to run it alongside. The FAQ has been very active, so thank you to those of you who've been submitting questions. If you haven't lately, I strongly suggest going back and just reading through all the questions in the FAQ. I think that would be a good idea. There's lots of good stuff in there, lots of good questions and thoughts and answers, that I've thought about that I think are worth sharing. So make a habit of checking it often. Maybe every time you sit down to do some work for the QEI, go see if there's anything new in the FAQ. Because again, there's really good information in there. And also, before you submit a question, go see, does somebody just ask that question? May save you a form and an email to go see that. Now, I have been spending a lot of my time answering your questions, and I just want to make sure you know that. Most of you know that because you've gotten a response from me, either for a question you submitted through the FAQ or a question you submitted on the lecture survey. I respond to many, many of the questions submitted on the lecture survey as soon as I can. I don't respond to every single one of them, so if you don't get a response to yours, it's probably because I know that you're about to go to a lab where that question is going to be addressed, and I think that question is better addressed in person, right? But if you haven't been, every time you get to the end of a lecture survey, put in a question for me if you have one. And again, you will get an answer if I think that an email is the best way to answer that question. And again, same thing with the FAQ. Go ahead and submit questions. I am spending a lot of time answering questions, and so you may as well be part of that conversation. I'd love to know what your questions are so I can help you. In terms of what's going to happen with the assignments that you just turned in, assignment 1, or the assignment you're about to turn in, depending on when you're watching this, once we're done grading, you will get feedback and a score by email, probably early next week. Okay, so that's what you can expect in terms of assignments. The quizzes, of course, you get automatic scores. This course is not for a grade, but we do give you scores with numbers on them because I think it's helpful for you to have a sense of how much of the assignment we thought was meeting the goals. All right, so the last thing I want to do, that's the end of logistics, so feel free to ask me logistical questions later or via email or FAQ if you have them, or even via the lecture survey for this video. I'm going to share my screen and I'm going to talk about the graphics of the day. Now, I don't think that all of you have seen every graphics of the day, right? Depending on what lab you're in, you would have seen different graphics of the day, but I thought the points that you guys are putting in the Google Docs discussing the graphics are excellent. Note that you are most welcome. In fact, you're encouraged to contribute to those Google Docs that discuss the graphic of the day at times outside of your lab, right? You're only definitely looking at them twice a week, but we're posting graphics of the day. Helen is posting graphics of the day every day. So I would love to see some comments outside of the lab groups if you're interested in thinking about those graphics. And even if you don't comment, I encourage you to take a look. It's good to see a variety of different types of data visualizations. So I read through all the comments that people posted with labs. I thought there were a lot of excellent points in there. What I'm going to do now is just go through a week's worth, the week one's worth of graphics, and just point out the thing that stands out to me the most about each of them. So here I'm looking at the first one, okay? And this graphic took me a minute to kind of figure out what exactly it's showing. And some of that is because I don't know a ton about sports, but mostly it's because of the way the graphic is set up. So we have 3 variables here. I see 3, right? I see in the x-axis average games played per season. I see on the y-axis a variable related to draft. And then I see using color, a variable related to average points per season. And what stood out to me here is that this may not be the best way to show those three variables. It looks to me like average points per season and average games played per season are the most continuous of these variables, and this giraffe variable is maybe not as numeric. Maybe it's a little bit more like a categorical variable. And I wonder, and I am not sure if this is totally appropriate, but I wondered if something like a scatter plot with average games on one axis, average points per season on another axis, and then maybe instead of each point writing the number 7, 3, 1, 2, undrafted, etc., might be better. That could be another version of this, right? So we'd have 1, 2, 3, 4, 5, 6, 7, 8 points on that scatter plot. There's really only 8 pieces of information being shown here. When you have a bar plot, however many bars you have, that's how many pieces of information are shown, right? But if you had a scatter plot with these 7 points, again, with this axis, and then maybe showing these numbers as the point symbol, I wonder if that would be more clear. It might not be, but the bigger picture point I'm making about this graphic is that often when you're commenting on a graphic or thinking about how to improve a graphic or trying to make your own graphic, you should not get stuck on the first way somebody tried to do it. There may be a totally different approach to showing that data that could possibly be better. And again, I have no idea whether the graphic I'm suggesting would look nice in this particular example, but I want you to get thinking about that idea that you're not stuck with the format of a particular graphic. Here's another one. I thought this was kind of exciting. There's a picture of the bubonic plague. So lots of interesting things about this one. One thing that stood out to me, I think this is the beginning of an example of a principle that you'll hear me mention lots of times this summer. And that is that every element of a graphic that represents a number needs to be proportional to the number it's representing. I'm going to say that again. Every element of a graphic that's meant to represent a number needs to be proportional to the number it's representing. And so, for example, that was true in this graphic, right? That this bar right here is shorter than this bar over here, proportional to the average games played per season, right? The sizes of these bars are proportional to the average games played per season, which is appropriate because that's what these bars are meant to represent. So there's an attempt to make that true here, but it's really not perfect. It can't be true because you have all these kind of spikes coming out of some of these. You have shadows on them, okay? So the total amount of space taken up by the picture corresponding to each of these different numbers is not perfectly proportional to the numbers. Now, I know some of these numbers are not very precise, right? But it's just something that stood out to me when I'm looking at this graphic, that because they are having fun and showing us pictures of what these plagues actually look like, they're losing an opportunity to exactly show us how these different numbers vary in proportion to one another. And you might decide that for this particular picture, that wasn't the point, we don't care. But during this program, at least, we are erring on the side of trying to think about how to make graphics show the data in as true of a way as possible, as opposed to making our graphics more like illustrations. And that's always the side I come down on. But if you become a magazine illustrator, you might end up with a different view. All right, this is a nice graphic. I think this one has a lot of good things about it. I like the scroll over. I like that there's no legend and instead you have labels directly on the graphic. So this is another principle that you'll hear me mention several times in this course. You can write these principles down. This principle is when you have the opportunity to label directly on the elements of the graphic instead of having a legend, do it, right? It's nice that this just says Democrat, even if I don't scroll over it. Right, this says independent, other, this says Republican. I don't need a little box off to the side that says red equals Republican, blue equals Democrat. This is typically much more clear than having a legend that the audience has to look back and forth between. But actually, so that's a good thing about this graphic. But the criticism I want to make is another one of my pet peeves or things that I want you to write down and think about. Much of the time, you want your axes to go all the way to 0. Okay, so if you look at this y-axis here, it goes from 30% to 65%. And they did that because that's the range of the data points. The problem is that if you cut off the axis at 30 and don't go all the way down to 0, it changes how these values look in proportion to each other. So if you just focus on this blue dot for the Democrats here and this red dot for the Republicans here, looking at this picture, if this is the bottom axis, it looks like the red dot is about twice the blue dot because it's twice as far from the bottom axis, it's twice as high. but actually the numbers are not twice as big as each other. This number is a 35%, this number is a 41%. Why is it that the red dot looks twice as high as the blue dot? Well, it's only because there was an arbitrary decision to cut off the axis at 30. When possible, even if you end up with a little extra white space, see if it looks okay to have your axes go all the way to 0. I'm being careful here. I don't want to say all axes all the time must go to 0, because sometimes it's just silly. For example, for year, right? That shouldn't go all the way down to the year 0. That doesn't make sense, right? Or sometimes all the numbers are right, near each other, and the point is not the proportion, just whether they're going up and down or something like that. But almost all the time, I think that it makes more sense for your axes to go all the way down to 0, because I do think that I do think that we could be misled by the relative, by how big certain numbers look relative to each other. All right, here's another one. And this was a weekend one, so I know it didn't get discussed a lot. This is worth looking at if you didn't get a chance to. I'll make one quick comment on this, which is I like the way that when I roll over it, I see the counts, right? So the percentages are nicely labeled on the sides. And if I want to also see the counts, I can see those by rolling over. And that's a very nice way to organize this information. It's helpful to see percentages and counts both. If you want to write down another principle in your list of graphical principles, for this one, I'd say, when possible, if there's room, write down the actual numbers that the elements of your graphic represent, right? I love that this is 3.2, 3.3, 3.1, not just the bars. Some bars are bigger than each other, right? Not just that I can see all these numbers are roughly between 2% and 3%, but I can actually read the numbers off the graphic. You don't want to do that if it makes things too messy, but when you have room, it is very nice to put the numbers directly on the graphic. All right, I've seen this plot before. I like this one a lot. If you didn't get a chance to look at it, you should. This is another one where I'm just going to point out that I love that the labels are directly on the graphic. The names are right there. Nobody wonders whose line this is. It's definitely Ben Franklin. There's not a legend, right? So I think that is really nice. A couple of people mentioned that it's too bad it's not obvious that you can toggle between, toggle on or off these different options. And I agree, it'd be nice if there was. I mean, it says it, but people don't read words. Right, so it'd be nice if there's a slightly more obvious way to do that. I also like these kind of info bubbles, but my main point here is that I like the labels directly on the graphic. Okay, a couple more. This one, I would say that this sort of violates the principle that every element of a graphic has to be proportional to the number it represents. Now here it might be technically true. I didn't calculate the areas of these different segments of the or chunks. I'll call them chunks of the circle, right? Like clearly this is supposed to be, China is supposed to be bigger than Japan. It's supposed to be bigger, relative to these proportions. It's possible they worked hard to make the areas come out just perfect, although I bet they didn't. But because each element is a totally different shape, I can't compare them, right? So if the point of having some of these elements bigger than others is to show me how big the numbers are relative to each other, then this graphic has not succeeded, right? Because I can't compare, right? It's hard to compare exactly how Russia compares to South Korea if I don't look at the exact numbers, because these two shapes are totally different. And this one I really like, okay? I thought this was a really nice graphic. I thought it was an example of a creative graphic because the y-axis is not something that you always think of as continuous. It's these dates here. And also when you have dates, you don't always think of putting year on the x-axis and day of the year, month or date on the y-axis. I really like that. I thought this was an example of a good compromise, a good balance between making a graphic beautiful and making it true to the data, right? So every one of these data points is a cherry blossom, and that makes this very lovely. Okay, and they chose brown here. So this looks like a cherry blossom tree if you kind of turn your head to the side. And I think that's really cool. But in no way does that take away from understanding, what the pattern of the data actually is. This is not like the one with the giant bubonic plague that isn't actually proportional to the number under it perfectly. These cherry blossoms are exactly in the right spots to represent the data. They're also transparent, which is nice. That's a nice thing to do when you have so many data points that they're all kind of on top of each other. Making them transparent is not that hard to do. At some point, I'll either show you how to do it or you'll end up asking me as you try to, or you'll end up Googling it as you go forward. But you can see there's some dark regions here, and those are places where there are more flowers on top of each other. So they did a really nice job, I thought, with this particular graphic. So I'll stop there. So you should now have if you're starting to take notes, a list of some graphical principles. And so I hope that those principles can guide you as you continue to discuss graphics with your group in your labs this week, and also as you look at graphics of the day whenever you want, and also as you just see graphics out there in the wild where you live. Hope you have a wonderful week. I hope that I'll see you at office hours, and I hope that I have opportunities to answer all of your thoughtful questions this week. Thank you so much for all the effort you're putting in.